Hello everyone, myself Mr. Sandeep and you are watching my channel Maths Guru. Today I am present here with a new video that is for class 10th and that is regarding for the very first chapter, that is real numbers, right? So let's start with our video. And do you know what are the real numbers? I know that you know the real numbers because already you have studied about the real numbers, but you don't know that real definition for this. Up to the class ninth, you have studied about rational and irrational numbers, right? So if you are going to collect these rational and irrational numbers, then what you will get, whatever the group you will get of the numbers, that will be a real numbers, right? So the definition of real number is what? The collection of rational as well as irrational number, that is called the real numbers. Now let's start with the chapter, and before starting the exercises I am going to discuss with you a few terms which are very important from this chapter. The first one is what? Euclid's division lemma. For any two positive integers a and b, there exists. Okay, before discussing that, let me tell you the things which you have already done in the junior classes. So suppose you are having two number, first number is 2 8 and you have to divide by 2. So what you will get here? 2 fours are 8. So what is remainder here? Remainder is equal to 0. Then start dividing 5 by 3. Then 3 ones are 3. The remainder is what? 2. Remainder, that is equal to 2. Right? Okay. That is less than this 3. Or you can say, uh, chalo, leave it. Remainder is less than 3. After that, and the A and B. Suppose you are going to divide any number, either the remainder can be 0 or it is greater than 0 but less than 1. Okay, this is enough for you. Okay, so in both the cases you can say either the remainder is 0 or remainder is less than the divisor. You can try with some more examples. Let us try one more. Okay, 21 divided by which number you should take? Let us take 5. 5 fours are 20. Again you are getting the remainder 1, and which is also less than the divisor, that is 5. Clear? So same we are going to say here. And one more thing, you have done one more formula in the junior classes, that is dividend is equal to divisor multiply by quotient plus remainder, right? So here what you will do, in place of dividend we are writing a, in place of divisor we are writing b, in place of quotient we are writing q, in place of remainder we are writing r. And r is always less than this number. What is this number? This is divisor, and here we have taken divisor as a b. So r, what the condition will become? R is less than b and greater than equal to 0. Clear? So same thing we are discussing here in the form of theorem that is called as Euclid's division lemma. For any two positive integer a and b, there exists a unique whole number q and r such that a is equal to bq plus r, and remainder, that is r is less than b, okay, that is divisor, and greater than equal to 0. Here a, b, q and r are called dividend, divisor, quotient and remainder respectively. So here I have cleared up this. I have given the name of the terms also, so it will be very easy for you to understand by relating with it with the junior classes. Okay, quotient, that dividend is equal to divisor multiply by quotient plus remainder, that is Euclid division lemma. Then come to the next term, that is Euclid division algorithm. So here word is new, but let us relate with the work you have done in the junior class, or and think about the construction. Whenever we are doing the construction work, you are just drawing it, constructing the triangle, quadrilateral, whatever is there. After that you are writing the steps of construction. Okay, whatever you have drawn, you are just writing it in the form of English. So step by step description is there for your construction, right? That is steps of construction for that. Otherwise you can also give another name, that is algorithm. Clear? So algorithm is what it is. Just Euclid's division algorithm is a process based on Euclid's division lemma. Okay, based on Euclid division lemma. Mean to say, when you will start solving the exercise, you will come to clear with the you will come to clear the with these terms from the question. Okay, practically when you will do, you will come to know about this theory work. Is a process based on the Euclid division lemma. It is repeated application of Euclid division lemma again and again. When you will repeat this this one formula, and that formula in steps will be called as a algorithm. Step by step description. Okay, algorithm. Then fundamental theorem of arithmetic. These are the important from the examination point of view. That's why I am discussing with you. Otherwise, in mathematics we are dealing less with the theory part. Fundamental theorem of arithmetic. Every composite number or positive integer can be expressed as the product of its primes. You know all these things, right? And this factorization is unique apart from the order in which the prime factors occur. Clear? Order. What do you mean by order? Suppose I have taken one example. The factors of 12 can be written as 2 into 2 into 3, or you can also write down, the another person will write down 3 into 2 into 2, then another person will write down 2 into 3 into 2. So only the order is different. Here 3 is written on the last number, here 3 comes on the first number, here comes on second number. Order can be different, but these primes number will be same. So this is called as the factorization of 12 is unique. 2 2 3 2 2 3 2 2 3, right? So this is fundamental theorem of arithmetic, right? Next one, relationship between HCF and LCM of two natural numbers. So the formula is LCM into HCF is equal to product of two numbers, and this relationship is applicable in case of two numbers only. Is it clear? So let's move to our first exercise, that is 1.1. The first question is to find out the HCF of two numbers. To find out the HCF of two numbers by using Euclid division algorithm. So I told you earlier that algorithm is what? That is nothing, only the step-by-step description. So we have to find out the HCF for 225 and 135. So this is a method we were using in the class 6. So 225 is greater than 135. So you will take 225 inside and 135 outside. Start dividing. 135 ones are 135. The remainder is what? That is 90. Again, this divisor will be shifting here. You will start dividing old divisor with this new remainder, right? Then 90 ones are 90, remainder is what? 45. Again this 90 will be shifted over here. 45 twos are 90. Now the remainder is 0. Whenever the remainder comes out to be 0, stop there only. You have to stop your process. Now how to write down in steps? Now you see, since 225 is greater than 135, therefore by Euclid's division lemma, 225, this is the quotient, is equal to divisor multiply by quotient, that is 1, plus remainder, that is equal to 90, right? Here 90 is what? Remainder, that is not equal to 0. This is not equal to 0. Then it means still we have to apply the same process. Again by applying Euclid's division lemma, 135, this time dividend is what? 135. Dividend is equal to divisor, that is 90, into quotient 1 plus remainder, that is equal to 45. Still remainder is not equal to 0. Again apply the same process by applying Euclid division lemma. 90, this 90 will shift here. 90 is equal to 45. You can see from here also. 90 is equal to 45 into 2 plus 0. This time we are getting remainder is equal to 0. Here remainder is equal to 0 and the last divisor is 45. Which is the last divisor? 45. So therefore HCF will be equal to 1. HCF will be equal to 45. I hope it is clear. Okay, so this is called as algorithm. I told you in the definition. Okay, it is based on the repeated equal division lemma. So this is what in the first step equal division lemma we are applying, again equal division lemma we are applying, again we are applying. So three times when we have applied, we have written in the steps form, and this is called as the algorithm, right? So after following this that for algorithm, we are able to find out the HCF of two number, that is equal to 45. Clear? So let's have a look on the exercise which is given in your NCRT. That first question is to find out the HCF of two numbers by using equal division algorithm. You can have a look on the exercise. You can take out the screenshot of this. Second part you have to try yourself. Third part also you have to try yourself. Okay. Then question number 2 is there. That is based on the theory. I am going to explain this. Then after that, question number 3 is there. Simply you have to find out the HCF of two number, that is 616 and 32. This will be your work. You have to try yourself. My work is to explain you question number 3, question number 2, 4 and 5. So let's come to the question number 2. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer, right? So let's prove it. We have to prove odd integer is always of the form 6q plus 1, 6q plus 3, 6q plus 5. So let's start with it. See here. Let's start from the old lines that let a be any integer, b is the divisor, and q is quotient. Let a be any integer, b is the divisor, and q is the quotient, and r is the remainder. Therefore, by Euclid division lemma. So, what division lemma says? That dividend is equal to divisor multiplied by quotient plus remainder, and remainder is always less than divisor and greater than equal to 0. So here in the question you can see we have to prove the odd integers are always of the form 6q plus 1, 6q plus 3 and 6q plus 5. So it means here you have to take b is equal to 6, right? So put here b is equal to 6, a is equal to 6q plus r. So now see what the change we have made here. Here in this step r is less than b, and in the next step we are putting b is equal to 6. It means in the next step you will change the value of b by 6. Replace b by 6. So in place of this b, 6 will come here. A is equal to 6q plus r, and r is less than 6. Clear? So this is the change we have made. Now what's the meaning of this? It means remainder is less than 6. Less than 6 means 5, 4, 3, 2, 1. Equal to 0 means equal to 0. So we will start putting a is equal to 6q plus remainder is 0, and next time remainder is 1, next time remainder is 2, next time 3, next time 4, next time 5. So these are the possibilities. R is less than 6, so 0, 1, 2, 3, 4, 5 can be the values of R, and by putting these value you will get 6q. This will be as it is 6q plus 1. 2 will be taken common here, that will give you 3q plus 1. Here again any number is coming common or not? 3 is coming common, but there is no use of it, so leave it like this only. Here 2 will be coming common, so 2 will be taken common. Inside will be, this is 6q, and this is looking 8 here, but this is 3. This is 3q plus 1. Here it is again looking 8, and this is 3. So this will be 2, 3q plus 2, and the next will be remaining as it is. Now you can see 6q, that is divisible by 2. That is, it means this is even number. 6q plus 1, that is not divisible by 2. Therefore it is odd number. Next one, 2 is common. It can be divided by 2. This is even number. Next one, not divided by 2. This is odd number. Next one, can be divisible by 2. It is even number. It is not divisible by 2, therefore it is an odd number. So therefore odd numbers are what? 6q plus 1, 6 cube plus 3, 6 cube plus 5. So therefore, odd positive integers are always of the form 6 cube plus 1, 6 cube plus 3 or 6 cube plus 5. This is the solution for question number 2, right? Then let's move to question number 4. They are saying the square of any positive integer. Let's have a look for you. Use equal division lemma to show that square of any positive integer is either of the form 3m or 3m plus 1. Right? Square of any positive integer. Mean to say, take any positive integer like 2. 2 square is equal to 4, and 4 can be written, they are saying, to prove that are always in the form 3m or 3m plus 1. Now let's start with the topic, with the next question. The starting will be same as the previous question. Let a be any integer, b is the divisor, q is the quotient, and r is the remainder. So therefore, by Euclid's division lemma, a will be equal to bq plus r, and where r is always less than b. Clear? From the question we have taken here, b is equal to 3, right? Why we have taken b is equal to 3? Because in the question it is given that we have to prove squares are always in the form 3m or 3m plus 1. So from there we have taken the hint and put b is equal to 3. A is equal to, in place of b you will write down 3q plus r. Here also in place of b you will write down 3. So here what is the meaning of this r less than 3? It means less than 3 means 210. Okay, so we are taking the possibility 0 1 2. 3q plus 0 is 3q, 3q plus 1 3q plus 2. So three numbers are possible, right? Integer can be of three forms for this question. Now let's start doing the square. The square of first number, a square 3q square, that will give you 9q square. From here you can take out 3 as common, inside it will be 3q square. In place of 3q square you can simply put m. Okay, just to show, just to make it simple. 3q square is a scalar quantity. Scalar means any number will be there, and that number, suppose that is equal to m, so we are just replacing it by m, so it will become 3m. Next one, scaling both hand side of this step, a is equal to 3q plus 1. A square is equal to 3q plus 1 square, that will give you what? A plus b whole square can be written as a square plus 2ab plus b square. This is equal to this one. From these two terms, first two terms, you can take out this 3 common. So what will be left here? 3q square plus 2, in the last plus 1 as it is, right? So what it becomes here, 3q square plus 2 is there, that will be a number, and simply to make it simple we are just replacing it by m from our side, so this will become 3m plus 1. So it means, again we have proved the square of any positive integer can be of the form 3m plus 1. Now the next last option, a square is equal to 3q plus 2 whole square, that is equal to what? Again a square plus 2ab plus b square, that is equal to, so what we are going to do here, that is different from other parts. This 4 will be split into two parts. 4 can be written as 3 plus 1, and from the first three terms, this one we have to take this 3 common. 3 can be taken as common, so inside it will be 3q square plus 4q plus 1. In the last plus 1 will be as it is, so this will form a number, and to make it simple we are just replacing it by m, so this will become 3m plus 1. So what we have proved, square of any positive integer, either that is of the form 3m or 3m plus 1. You can see in these last two parts it comes out to be 3m plus 1. In the first part it is 3m, right? So therefore in the last line you can write down, therefore the square of any positive integer is either of the form 3m or 3m plus 1, and this is the same line as given in the question. Then come to the last one, that is question number 5, and that is exactly matching with the fourth question. In the fourth question we have proved the square of any positive integer, and in the fifth question you will prove the cube of any positive integer. So let's start with the last question. Let A be any positive integer, B is the divisor, Q is the quotient, and R is the remainder. Therefore, by Euclid division lemma, A is equal to BQ plus R, where R is less than B and greater than equal to, see here clearly, this is equal to sign also here, right? R is greater than equal to 0. So here B is equal to 3. But in the question that is given M, 9M. Okay. But if you will put here B is equal to 9, then also the question can be solved. But the numbers you will get in the calculation that will be bigger. So to make our calculation easy, we have tried with B is equal to 3 and we are able to complete our question. So that's why we can take B is equal to 3 also here, right? So let us take B is equal to 3. So what will be the change here? A will be equal to, in place of B, 3Q plus R, and here also we will make the change, R is less than 3, greater than equal to 0, greater than or equal to 0. It means the possible values of R can be 0, 1 or 2. So here we goes with the possibilities 3Q plus 0, 3Q plus 1, 3Q plus 2, and this will give you what? First line will give you 3Q and rest will remain as it is. Clear? Now this question is regarding the cube. Cube means in the last question we have done the squares on both hand side, and this time we will do cubing on both sides. So for the first option, a cube is equal to 3Q whole cube. That will give you what? 27Q cube. From 27 we can take out 9 as common. Inside the bracket it will be 3Q cube. And to make it simple, we will write down, replace it by M. So this will give you 9M, right? Then move to the next option. That is A is equal to 3Q plus 1. Cubing on both hand side. That will give you A cube is equal to 3Q plus 1 whole cube. For this, you must know the formula A plus B whole cube. A cube plus 3A square B plus 3AB square plus B cube you have to write down in the last. You can mention it because here we are just dragging it in the last. So it's better if you write down in the starting only because this is the standard form given in all the books. A cube plus 3A square B plus 3AB square plus B cube. Now see what I am doing here from these three terms, right? We can take out this 9 as common. So inside the bracket whatever is there after taking common, it will be written inside the bracket plus 1 as it is, right? So this will form a number. You can just replace it for the simplification as M. So 9M plus 1 it becomes. So what we have proved, the cube of any positive integer can be of the form 9M plus 1. First we have proved cube of any positive integer can be of the form 9M, right? Now the next option. A is equal to 3Q plus 2. Cubing on both hand side. A cube is equal to 3Q plus 2 whole cube is equal to 3A cube plus 3A square B plus 3AB square plus B cube. You can see here that this is 2 cube. Okay. So after the calculation you will get here these numbers, right? From starting three numbers you can take out this 9 as common. So inside the bracket whatever is there you can get a number from here after putting the value, proper value of q. So we are just for the simplification we are replacing it by n again. So this will become 9m plus 8 as it is. So it means the cube of the any positive integer can also be of the form 9m plus 8. So this was the question only. We have to prove that positive integer, cube of any positive integer is in the form of 9m, 9m plus 1 or 9m plus 8. So this was the question to prove here, and we have proved the cube of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8, right? I hope you have understood, and this exercise is very important from the examination point of view. The very first question to find out the HCF of two numbers by writing the Euclid division lemma, that is also important for 2 marks, and these theoretical questions are important for 4 marks, 3 or 4 marks, whatever is there they become. Okay, so prepare it well, and thanks for watching the video. If you have understood properly, then like the video. Thanks a lot for watching the video.